Alright, so looking at piecewise functions, we're going to start by looking at number 8 here. We're going to write a piecewise defined function for the graph, including the domain for each part. So the domain is just our x coordinates, and then our range is our output or our y-axis coordinates. So when we start with this, we are going to find the slope for the first section here. So starting from 0 to about 5, we can find our slope. So I'm just going to start by, I'm starting at 0, 0. And our second point is 5, 2. We're going to use those 2 points to find our slope. So we're going from 2 to 0, looking at our x coordinates, and then looking at our y coordinates, we're going from 2 to 0, and then our x coordinates are going from 5 to 0. So this line has a positive slope since it's increasing, and it is increasing at a rate of 2 units of the y-axis over 5. We don't have any units, so just 2 over 5 units for our slope. And then using our point slope formula, we can find the equation for that first section of our graph, and that first section is going from our y-axis to just there at 5. So point slope form is y minus y1 equals our slope times x minus x1. And for x1 and y1, we're going to pick a point on our line. I'm going to choose 0, 0 just to keep things simple, or as simple as possible. Our slope is 2 over 5, and our x coordinate is 0. So using distribution to get rid of our parentheses, our equation for that first section is y equals 2/5 x. Now we're going to find the equation for our second section of the graph, and it's going from 5 to 6, where it's changing. So then we're going to find the slope of that line there. Clean this up a little bit. So we're going to pick our 2 endpoints. So we have a point at 5, 2 and a point at 6, 9. So again, we're going to find the slope. So we're going to take the difference in our y coordinates, so that's 9 minus 2. And then difference in our x coordinates, so 6 minus 5. So that middle section has a slope of 7 over 1. We're going to use our point slope formula to find the equation of that line. So y minus y1 equals m times the quantity x minus x1. Now we need to pick a point. I'm going to choose this first point here. So y minus our y coordinate of 2 equals 7 over x minus 5. Using algebra to get rid of parentheses, y minus 2 equals 7x minus 35. So y minus 2, let's see, so we can move that 2 over. So we'll add that to both sides. So y equals 7x minus 33. So that middle section of our graph has an equation of 7x minus 33. And then we're going to find the equation for the last segment of the graph. So that goes from 6 to, let's see, what is that, 11? So we're going to repeat the process. We're going to pick our beginning point. So we started at 6, 9, and we're going up to 11, 14. So those are the 2 points we're going to use to find our slope. So we're going to take the difference in our y-coordinates, so 14 minus 9, over the difference in our x-coordinates of 11 minus 6. So we have a slope of 5 over 5, or 1. And then using point slope form, and then solving, so it's in slope-intercept form. We have y equals x plus 5. Alright, so we have equations for our 3 sections, but it's not written in piecewise defined function. So to pull that all together, and to write it as one function instead of 3 different, we have f of x equals, for our first leg, we have 2/5 x, and that is for when our x value is between 0 and 5. And then our next equation, we have 7x minus 33, and that's when our x value is between 5 and 6. Just forgot my inequality symbol. And then our last equation, x plus 5, is for when x is greater than or equal to 6. So that's our piecewise function there. Looking at the domain for this function is going from 0, our starting point here, it goes from 0 to 11, so our domain for the total function. And our range is going from 0 all the way up to 14. Since there's no arrows, it does not indicate that it goes on forever. So we're going to go from 0 all the way up to 14. Alright, so now if we're going to look at analyzing this graph to compare the sections, since the slope of our first section is 2/5, the slope of our second section is 7, and the slope of our last leg is 1, we have the slowest rate of change in the first leg, because 2 is the smallest of our slope numbers. We have the greatest rate of change increase in our middle leg, where our slope is 7, which is the highest of our 3 numbers. And then in the middle, our middle rate of change is at the end, where our rate of change is 1. And so that is how you would compare the different sections of a piecewise function and writing the equations that go with your graph.